Number 23 on the AMC 12B. Let's explore how we can solve this problem. Okay, so we have set of all integers z greater than 1, such that for all pairs of non-negative integers x and y, where x is less than y is less than z, the remainder when 2025x is divided by z is less than the remainder when 2025y is divided by z. And we're summing all these elements of z. Okay, this is a lot to process. What does this question really mean? Okay, so we have x is less than y is less than z. So we have 3 integers, right? And we have non-negative integers x, y. Okay, so all these integers are non-negative. Z is specifically positive. When the remainder when 2025 is divided by z is less than the remainder when 2025 is divided by y is divided by z, what does that mean here, right? So 2025x, imagine like we take this, it's not really mod z because imagine the remainder when this is divided by z, it's going to be some number between z0 and z minus 1, right? 0 to z minus 1, 0 to z minus 1, right? Somewhere in this range. And same thing for 2025y. That's also going to be in this range from 0 to z minus 1. They're both going to have these remainders. And basically all this is saying is that we pick a value of z greater than 1. Let's just say we pick 3, right? Let's say we pick 3. So from 0 to 2, these remainders from 2025 x and y are divided by 3 for all non-negative x less than y, where x and y are less than 3. So maybe, 0 and 2. 0, 2, or maybe 1, 2, or 0, or yeah, that's all the cases there are for 0, 1, 0, 1, maybe, right? So we're saying for all these pairs of x and y, where they're less than or equal to, or less than 3, then we have that whenever x is less than y, so this is going to be, the remainder is going to be, 2025x is going to be less than the remainder of 2025y. So let's explore a concrete example just to get the feel for it. And maybe z equals 3 is too small now that I think about it. Let's try z equals 6, just randomly, right? So, and then let's say like, I don't know, we pick x equals 2 and then y equals 3, right? So we have like 2025x and then 2025y. Right, first of all, we're looking at the remainder when this is divided by 6. So we really only care about 2025 mod 6. Same thing here. We only care about the part over here that's the only part. We don't care about the multiple of 6 part of this. So you can replace 2025. Well, notice that what is divisible by 6? Now, let's say 2022 is divisible by 6, right? Imagine here, this is even and a multiple of 3 since sum of digits is 6. So 2025x is going to be the same as 3x mod z, or mod 6, right? We pick it to be 6. And same thing here, right? So is it true, for example, when z equals 6, is it always true that for any x and y less than 6, where x is less than y and they're both non-negative, so they're both at least 0, is it always true that this remainder, when 3x and 3y are divided by 6, is it always true that 3x, the remainder, is less than 3y, the remainder? Well, let's see. Maybe let's say x is 1, and let's just explore all these values, right? So like x and y are just, we're picking 2 of them, right? So maybe x is 1, and then maybe y is 2, right? Oh, look here. The remainder is 3. Here, the remainder is 2. So we have x is less than y. Is the remainder of 2025x, or 3x, less than the remainder of 2025y, or 3y? Well, no, because 3 is not less than 0. So 6 would not work. Okay, maybe let's try another example. Maybe let's try 4, right? 4, why not? So I'm just trying to show you like how you can approach this, just trying a few values of c, seeing what's happening here maybe, really understanding what's going on in this problem. Because this problem here, it's really just about figuring out the pattern. And to do that, the best way is just try a few values if you're unsure, right? We're not here, my mod 4 now, right? Here's the thing, 2025x mod 4 is just x mod 4. 2025y mod 4 is just y mod 4. So for these values of x and y less than 4, the remainder when 2025x is divided by z is just x and y itself. So if x is less than y, well, of course, then the remainder when 2025x is going to be less than the remainder of 2025y, because the remainder is just x and y themselves. So of course, the remainders, this is going to be true. The remainders are going to be, remainder of x will be less than the remainder of y, because the remainder of x is literally x. The remainder of y is literally y. So for example, 4 is a case that does work. 4 does work. But of course, the answer is much larger than 4. Okay, so what seems to be going on here, right? We noticed here that in the first case, we had this is equal to 3x mod 6. And now we have it's x mod 4. So maybe x, we know x works, right? So really the key idea here, okay, let's explore the more general case. Let's try and figure out our insights here. Really, we don't care about 2025. We're trying to see what is the remainder when 2025 is divided by z. So let's just say 2025 leaves a remainder of, I don't know, let's say it leaves a remainder of a when divided by z. Right, and I don't want to say 2025 mod z here because theoretically mod could be like a different value. So let's just say 2025 is let's say 2025 has a remainder of a when divided by z. So we were really only caring about the value of a. We don't really care about 2025 itself, right? We're really just looking at, we can think of, we're looking at ax and ay, right? That's all we care about. Ax and ay. So when will ax, whenever x is less than y, we need ax to be less than ay. So x and y are just basically, anything that ranges from 0 to z minus 1, where x is less than y, and then we're looking at ax and ay mod z. So what are some values of a, right? What if a is 0? Let's say z is a divisor of 2025. Well then, if a is 0, right, then this is just going to be always going to leave a remainder of 0, and this is also always going to leave a remainder of 0. So is it true that this remainder is less than the remainder of 2025y if they're both 0? Well, no, because they're always going to be the same. So a equals 0 does not work. What about a equals 1, right? Then the remainders are just x and y themselves. So of course, like 2025x and 2025y will have remainders of x and y. So of course, if x is less than y, we have the remainders will be, the remainder of 2025x will be less than the remainder of 2025y when divided by z, right? Because we know that it leaves a remainder of a, or in this case 1, when divided by z. And that was exactly what we saw with the case with 4, right? We saw 4, as you can see, 4 is a divisor of z. So that is a divisor, basically 2025 leaves a remainder of, remainder. It leaves a remainder of 1 when divided by 4. So any value for which a equals 1, that always works. So what does it mean for a to be 1, right? We need 2025 leaves a remainder of 1 when divided by z. 2025 is 1 mod z. So 2024 is 0 mod z. So it's just a factor, any factor of 2024 except for 1 itself, because 2025 does not leave a remainder of 1 when divided by 1. It leaves a remainder of 0. And then also we anyways need z greater than 1 in our problem. So anything else like 2, 4, so on, they all do work because 2025 leaves a remainder of 1 when divided by them. But 1 doesn't work. So all the factors of 2024 except for 1 work. So what is the sum of all of these factors? 2024 is 2 cubed times 11 times 23. That's always good to know. And so what is the sum of the factors? We use our standard sum of factors trick. Pretty straightforward. 1 plus 2 plus 4 plus 8. 1 plus 11. 1 plus 23. That's 15 times 12 times 24. That's 180 times 24. That's 4320. So the sum of the factors is 4320, but we're accounting an extra 1 because 1 doesn't work, right? 2024 does not leave a remainder of 1 when divided by 1. So we subtract 1, we get 4319. And actually in the choice, you would know this is the answer right away because this is the highest possible number. But let's just see why for a minute, why higher values of a do not actually work. So let's say a equals 2, right? Let's say this remainder is 2 when divided by z. Now we have 2x and 2y. So is it always going to be true that whenever x is less than y, the remainder of 2x when divided by z is less than 2y when divided by z? Well, this is not true. To see this why, let's imagine, right, let's just pick, what's the factor of 2023? Let's say 7, right? I'm just trying to show it for illustration's sake, right? And we kind of saw this with the 3x and 3y earlier, right? We saw, let's say it leaves a remainder of 2 when divided by 7. So for example, we could pick, let's say x equals 2, and then let's say y equals 4, right? We just pick the smallest value of y such that it just tips over beyond 7, right? So we have, okay, 2, 4, 6, and then 8 goes all the way back down to 1. And as you can see here, like we have, okay, 1, 2. Okay, fine. The remainder when 2y is divided by 7 is more than the remainder of 2x. Okay, then we have 2, 4. Then we have 3, 6. And then soon, next time we have 4, but this one becomes 8 or 1. So kind of the 2y goes down all the way till near 0 again. So now 2x is bigger remainder than 2y. And a concrete example of this is, let's say x equals 4 and x equals 2, y equals 4. Because at y equals 4, this will leave a remainder of 8 or 1 when divided by 7. And at x equals 2, this will leave a remainder of 4 when divided by 7. So even though 2 is less than 4, we have found an example where this is not true. But we need it to be true for all pairs of non-negative integers. So this won't work. And just like we saw earlier, same thing with 3, right? We just picked a point where, I don't know, let's say we did 6 example from earlier, right? We picked a point where it just tips over for y, and that gives us an example of a case where it doesn't hold true. Like it will hold true in the beginning, right? In the beginning, we have 3 times, let's say 2 is always going to be greater than 3 times the remainder of 3, or not in this case actually, but so yeah, let's say 3 times, let's just pick x equals 1 and y equals 2, right? So 3 times 2 leaves a remainder of 0 when divided by 6. 1 times 3 leaves a remainder of 3 when divided by 6. And clearly, we have this remainder is not bigger than 3, even though y is greater than x. So this is a contradiction. So we see here that we can just pick the value of y. We can pick a pretty low value of x, and then we can just pick the value of y just before it tips over. And we can see that even though x is less than y, the remainders are not less than that because 1 has went beyond the value of z and gone back down to something near 0. Yeah, that's like kind of, I was trying to explain it as well as I could because it's a little bit tricky to wrap your head around. But there's actually a problem from the USA JMO a few years back that I think was similar to this, I think from 2012, I believe. So you can definitely check that problem out if you're interested for, more of the rigorous side of things and how this works. So yeah, I hope you enjoyed this video. Thanks for watching.